Let's say you came across this question in your Jamb exam. How will you solve it? It is very easy. Now let's solve together. The question says, what are the values of x, y, and z respectively in the equation? Now, this must be noted. Whenever you see the word equation, it is the same as reaction in chemistry. Listen carefully. Whenever you see the word equation, reactions, they are the same in chemistry. So this question is extremely very easy. Before we go ahead to solve any practice question, be it in chemistry, biology, physics, use of English or mathematics, we have to know specifically the topic to which that question is from. And from the look of things, this particular question on the board is on a very important aspect in chemistry, and it is simply called balancing chemical reactions. How did I know? It is very easy. I believe you can see a reaction given to us, and in the front of the elements and compounds, we have letters written in front of elements and compounds in this reaction. That tells us that there should be a number standing in place of those alphabets. Are you there? And those numbers is what they want us to determine. So we can now agree that this question is on balancing chemical reactions or balancing chemical equations. Are you there? So the question we ask ourselves, how do we do this? It is very easy. I already have a full video lesson on my YouTube channel where I explain how to balance chemical reactions. You can see the video here on the screen. So at the end of watching this video, at the end of watching how I'm going to solve this question, make sure you go watch that full video lesson on my channel. And also at the end of watching this lesson, I'm going to give you a practice question so you solve and provide the answer in the comment section. So let's get into solving this question. It is very easy. Solution. All right. So do this is extremely very easy. Now, please note this. You can see that we were given a reaction, and this must be noted about a reaction. It must be noted here that a reaction has two sides. Are you there? We have the left-hand side of a reaction and as well as the right-hand side of a reaction. The left-hand side of a reaction is simply called the reactant side, whereby the right-hand side of a reaction is called the product side. So the first step to take whenever you are about balancing a chemical reaction is simply to identify the elements you are having in your left and as well as in your right hand side. So listen carefully. All right, so what we'll do first is simply to use a line to separate the two sides of the reaction. Remember, this is the left hand side and this is the right hand side. So here we are having the left hand side of the reaction, whereby here we are having what? The right hand side of a reaction. Are you there? So moving further, the next step to take is simply to identify the elements you are having in your left hand side and as well as the elements you are having in your right hand side. Please look at what I said. I said identify elements. So in this my left, what is the first element I am seeing? The first element I'm seeing is Cu, and Cu is copper. Remember, X, Y, and Z, they are not elements. They are basically, they just wrote them there because numbers should be in place of these, letters. Are you there? So these are the unknown. So they are not elements. I said identify elements. So copper is the first element I'm seeing. We'll come to these other guys. I'm coming. We'll take it step by step. So moving further, we are done with this guy, which is copper. So let's go over to this compound and bring out the elements that are forming this compound. So here I think I can see H, and H is hydrogen. I'll write it down. Moving further, this is nitrogen. It's another element found in the left. I'm going to write it down as well. Are you there? So moving further, I can see another element. Oh, oxygen. Please, you are writing out the element. You are not writing any number standing in front of the element or any number beside the element. What we are doing right now is simply to write out the element itself, not anything else. Are you there? So you can see that we've brought out all the elements that is in the left hand side of this reaction. And to balance a chemical reaction, the numbers of elements you're having in the left should equal the number of elements you have in your right. But chemically, it should be said like this: the numbers of atoms of elements you're having in your left should equal the number of atoms of elements you have in your right. We'll come to that. Listen carefully. So definitely my right hand side is supposed to be the same element that should be my right hand side, but let's just check. All right. So the first one I'm seeing also is copper. I said write out the element. You are not writing any number. You are not writing any brackets down. You're just writing the element. Moving further, I can see nitrogen is another element. Then, because I can't put it in place of hydrogen, all right, I'll just take it down. So we are having nitrogen. I believe you are following me. Moving further, the other element I'm seeing is oxygen. O. Oxygen. O. Then I put it here. Are you there? So moving further, I told you that business with the numbers for now. We'll come to that. Moving further, I think another element I'm seeing is H, and that element is hydrogen. I'm going to put it here. Are you there? So you can see that we've actually brought out the element we're having in the left and as well as the right hand side of this reaction. If you observe, you can see that the last element we talked about was hydrogen. Another element here is oxygen. I can't write oxygen again because oxygen was already seen initially here. Are you there? Both of them are oxygen, oxygen. So I cannot put another oxygen. We'll use this oxygen to get whatever I want to get. Just listen. And this is nitrogen again. I can't write another nitrogen down because nitrogen was already, seen. And lastly, this is another oxygen. I cannot put it there. I believe you are following me. The sole aim of this question is to basically get what numbers should be standing in place of x, in place of y, and place of there's another x here. All right, so anything we get for the x should be in these two positions. Just listen, I'm going to explain how it is done. It is very simple, whereby we are still looking for z. So all these things are simple. Just listen to the way I'm going to balance this reaction. So moving further, the next step to take is simply to basically bring out the numbers of atoms of these elements you are seeing as given to you by the question. You can see that this reaction is not balanced. So you are bringing out the number of elements you have in your left and right hand side as seen in the question given to you. So this is what I mean. For copper in the left, how many atoms of copper? That's the right word to say. How many atoms of copper? I can just say how many elements of copper are we seeing there? But we use the word how many atoms. So how many copper can you see in the left? From the look of things, I am seeing just one copper. So I'll record it to be one copper. Are you there? The way I'm going to solve this question, this is the way you have to solve any other question you see under this aspect. On my YouTube channel, I have a well-structured video lesson where I explain how to balance chemical reactions. So at the end of watching this video, make sure you go to my channel to watch that particular lesson. It's going to help you greatly. Moving further, moving over to hydrogen because we are done with copper. So how many hydrogen? Remember I told you for now, let's just relax with X, Y, X, and Z. Let's just leave those things alone. Let's just feel it doesn't exist. It was not given. But we are looking for the numbers that should be in front of these things. Just listen, I'm going to explain. So moving further, how many hydrogen can we see in the left? Wow, I can see just one hydrogen. Are you seeing any number in front of hydrogen or at the back of hydrogen? No, we are just seeing hydrogen H. So hydrogen as well is 1. Are you there? Moving over to nitrogen. How many nitrogen can we see as well? we can see just one nitrogen, then nitrogen remains one in the left. Are you there? We'll go over to our right zone and get the number of atoms of this element present in the right. And at the end of doing this, we'll now start balancing. And it's very simple. Moving further, now let's get into oxygen. How many oxygen atoms can we see in the left? You can see that 3 was standing in front, like you can see 3 beside oxygen. All right, so that tells us that we have 3 oxygen atoms. Are you there? 3 oxygen atoms. So here oxygen becomes 3. So moving further, you can see we've analyzed all the numbers of atoms of the elements in the left. Let's do the same for the right hand side. So copper, please, we have to be careful with this compound with a bracket. These things are simple, just listen. All right, so before we even go over to start analyzing the right hand side, I can rewrite the way this guy is. Are you there? I can rewrite the way it is. But before I rewrite it, let's just relax. I don't want you to get confused. So let me just leave it like that. I'll still explain it for you to be able to understand. So there is no need to rewrite. There is a reason I actually did not rewrite it. All right, but in other cases, I'm going to rewrite. Just listen. So now, how many copper can we see here? Remember, you can see NO3 was in a bracket and 2 was outside. It means that this 2 that is outside is affecting only NO3. 2 that is outside is not affecting copper. So automatically we still have just 1 copper. Are you there? So copper in the right hand side is still 1. Are you there? So let us progress to get how many atoms of hydrogen are in the right hand side, because hydrogen, we have to be very careful here. So moving further, let's analyze for hydrogen. All right, hydrogen was not even present here, so we'll leave this alone and go over to the other place. We can see hydrogen, and I believe you can see hydrogen in water. So how many hydrogen atoms can you see? All right, listen carefully. Let's assume 4 was not in water. Let's assume 4 was not there. So if 4 is not here, how many hydrogen can you see? You can see just 2 hydrogen. Remember, we analyzed it like that for oxygen, that we had 3 oxygen. So let's say 4 was not here, we have 2 hydrogen. But 4 was not standing in front of water. This 4 standing in front of water means that 4 is affecting hydrogen and say 4 is affecting oxygen. Are you there? 4 is affecting 2 elements, the 2 elements in that compound. So let's use the 4 now to affect hydrogen that is already 2. So the way it works, those numbers standing in front of compounds basically times the elements in those compounds. So since we have 4 here, so it's going to be 4 times 2. 4 times 2, what is that? 8. So in total, we have 8 hydrogen atoms. Are you there? It is very easy. I believe you understood how we got 8, because initially it was 2 hydrogen, but 4 was standing in front of water in general. The 4 is affecting hydrogen, and as well as the 4 is affecting oxygen. And I told you those numbers standing in front of those compounds means those numbers are timesing all the elements in those compounds. So 4 is timesing the hydrogen that is already 2, making it 8 hydrogen, and this same 4 is timesing oxygen. You can see that there is no number standing in front of oxygen, so automatically in water we have 4 oxygen atoms. I believe you are following. It is very simple. So you can see we've analyzed for hydrogen. Let's go over to the next element, which is nitrogen, and analyze for how many atoms of nitrogen do we have. It is very easy, just listen carefully. Moving over to nitrogen, all right, you can see that nitrogen appeared in 2 places in this reaction. Nitrogen appeared here and nitrogen appeared here. So first of all, let us look at nitrogen here. Let's get how many nitrogen atoms can we see in this compound. It is very easy. Let us say that 2 was not present, like 2 was not, outside this bracket. Let's just say that nothing was there. How many nitrogen can we see? 1. But now 2 was not outside the bracket, means that 2 is affecting everything inside the bracket. So it's going to be 2 times the nitrogen that was already 1. So 2 times 1, 2 times 1, that is 2. So in this compound alone, we have 2 nitrogen atoms. We are not done. Are you there? I cannot just come here and write 2 because nitrogen was also present in the right hand side. So please listen carefully. This thing is very simple. So what do we do next? So the next step to take is to determine how many nitrogen we're having here as well. So from the look of it, I told you the letters they are bringing, we don't have business with them for now. We'll use them at the end to get the answer. But first of all, leave those things. So nitrogen here is 1. So the 1 nitrogen we have here plus the 2 nitrogen we have here already. So you add them. So 2 plus 1, what is that? 3. So in total, in the right, we have 3 nitrogen atoms. Are you there? So here becomes 3. I believe you are following me. All these things are very simple. So finally, let us get the number of atoms for oxygen before we start balancing this reaction. So what do we do next? You can see that oxygen appeared in the 3 compounds. So we have to be careful. So you can see, first of all, let's say 2 was not here. Here becomes just 3 oxygen. But 2 was outside. It means that 2 will times everything inside the bracket. So 2 will affect oxygen here. So it's going to be 2 times 3. What's that? 6. So here alone, we have 6 oxygen atoms. We are not done. Moving over to water, you can see oxygen was here. So 4 will times. I told you this already. So 4 times this oxygen, making here alone to be 4 oxygen atoms. But how many oxygen atoms did we get here? We had 6. Yes, now we had 6 oxygen atoms. Do you understand? In water, we had 4 oxygen atoms, right? 4 oxygen atoms, all right? Whereby, lastly, in the last compound, we have just 1, all right? So here we have just 1 oxygen atom. So what do we do next is to now add all of them together. So 6 oxygen atom here plus 4 oxygen atom here, that's 10 oxygen atom plus the last oxygen, that is 11 oxygen atom. So in the right hand side we have what? 11 oxygen what? Atom. So all this must be noted. I believe you understand how all of this was determined. So moving further, let's now start balancing this reaction. To do that is extremely very easy. There's something I will tell you, so you just follow those steps in balancing any other type of reaction in the Jamb exam. And to do that, they are very simple. The reason I'm taking my time to solve this question, so you don't have any issues whenever you encounter questions on this aspect. Moving further, what do we do? It's very simple. On my YouTube channel where I've explained how to balance chemical reaction, I've solved many examples, all right, many questions, and I've given out many practice questions as well. So make sure you go watch those lessons. So moving further, what do we do next? Whenever you are balancing a reaction, you inspect the 2 sides. You inspect the right hand side and as well as the left hand side and see the ones that have larger numbers. All right, from the look of things, this has larger numbers. So you can see that the right hand side in this reaction have larger numbers. Then to balance this reaction, simply focus more on the left hand side first. Are you there? So if you observe copper in both sides, copper was balanced. So we'll leave copper for now. Though at the end of everything, we are still to alter copper. In some other reactions, we might not alter it. In this reaction, I don't know if we are altering it or not, but when we solve, we'll get the answer. Listen. So 1, 1, they are balanced for now. We'll leave it alone. Hydrogen is not balanced. Hydrogen here is 8 and hydrogen here is 1. So we have to try to balance it. Are you there? So what do? We have to now look at hydrogen and try to think what to put in hydrogen. So listen carefully. This reaction is a bit technical, but it is very simple. So what do? Please listen carefully. You can see now that we want to start balancing the 2 hydrogens in the right and left. So because it was not balanced, in the left we have 1, in the right we have 8. So to balance this hydrogen, what do we put? What number do we actually put? Because here is something you should know. In my video, I explained this on my full video lesson on balancing chemical reaction. I said that whenever you are balancing a reaction, you are adding numbers at the front of compounds or elements. You can't add numbers between elements. Are you there? So I cannot put a number between any element. The numbers we are put to balance this reaction is simply should be at the front of these compounds. Are you there? They are all easy. So please listen carefully. So what do? To balance hydrogen, this is the only place hydrogen was found in the left. what do we do? It's very simple. It's wise for us to simply put, hydrogen here all together was in this side. All the places hydrogen appeared was 8. Are you there? So it's wise for me to replace this y with 8. Listen. So let us wipe out y. Remember, let's try to remember the position y was present. This is where y was before. So I'm going to just put it, y was here initially. Let me put 8 so that we don't forget. So if you observe, I've written 8 in front of HNO3 because I told you whenever a number is standing in front of a compound, is affecting every single element in that compound. So 8 is affecting hydrogen, 8 is affecting nitrogen, 8 is affecting oxygen. Are you there? So if you observe, 8 has affected hydrogen, making us in the left to now have 8 hydrogen atoms. So then this one I'm going to cancel it out to put here to be 8. Do you understand? So now, because I'm still going to alter other things, because me putting 8 here, it has altered many other things. It has altered this nitrogen. Remember, nitrogen was a 1 here, but because 8 was present, so it's making it 8, because this 8 is times in them. So here will now become 8 nitrogen as well. So then I'm going to cancel this to put 8. Do you understand? It's very simple. You can say I cancelled it to put 8. So let's check for oxygen because this 8 has affected it as well. Do you understand? So 8 will not be 8 times the 3. 8 times the 3. If nothing was here, it's going to be just 8 oxygen. But now there's 3. So 8 times 3, what is that? That is 24 oxygen atoms. Are you there? So here becomes 24. So this place that was 3, I'm going to cancel it to put what? 24. So if you observe, me doing this now, I've made this other side to be lesser. Do you understand? So since we balance this, sure, this is the right way to do it. So we'll now focus, put our attention on this other side to balance it as well. Because when we added numbers, the numbers we added, was now above all of these things. So what we do now, come back to this right hand side to think what to put. All these things are simple. Just listen carefully. Remember, we'll come to copper. We'll leave that for now because initially it was just balance. So we'll come to it at the end of this question. So moving further, let's go back to our right hand side. All right, you can see now the hydrogen is already balanced 888. 88. All right, so let's now look for the one that is more balanced, which is nitrogen and nitrogen. In the right, nitrogen was 3. All right, so let's try to look for nitrogen. This is nitrogen. Nitrogen appeared here, and also nitrogen appeared in this compound. So let's now try to make sure that the nitrogen in our right should be 8 as well. So what should we do? That will be the question we ask ourselves. What should we do? It is very simple. Now, this question is simple. You have to just be wise. You have to be smart. That will be what I'll tell you. Now, moving further, let us focus on balancing nitrogen. At the left, nitrogen was 8. In the right, it was 3. All right, so we have to make sure that it's still 8. So you can see nitrogen appeared here, and as well nitrogen appeared here. So do you think it's wise for me to just come in front of remove Z? Remember Z is here and just put 8. If I do that, nitrogen will now be more than 8. Do you understand? Because I know you now say, oh, nitrogen is already 8 now. Let me put the 8 here. Let me remove this 3 and just put 8. No, nitrogen is still here. Nitrogen here is 2. So what do you think I should do to make sure that nitrogen is balanced? This question is very simple. Just watch, just listen. It's not wise for me to put 8 here. I'm going to remove it and let's say, all right, so let's put, listen, let's put for instance 2. So if I put 2 in front of nitrogen, because nitrogen was present here as well, so just leave it. Let's say I put 2 nitrogen here. So nitrogen automatically becomes 2 in 2NO. So nitrogen here is 2. So let's try to think as well, because nitrogen here is already 2. All right, without adding anything in front of X here. Just listen. Nitrogen is already 2. All right. Here, nitrogen is already 2 here, making everything to be 4 nitrogen. We've not added anything because when we add a number here, it's going to affect everything in the compound. Do you understand? So what should we now do? Because we have been listening. We're already having 2 here. We're already having 2 here. That is 4 already. So what do we add to make sure that nitrogen is balanced? This question is simple. It is mathematics. See, listen. We already have 2 here. We already have 2 here. Because when I put any number here, it's going to times. So what do we do? Let's be very smart here. So what we just do is this. Let's be very smart. All right. Let's leave this 2 alone. We know nitrogen there is 2. Let's leave it alone. Let's focus on this. Let's try to make sure that nitrogen in this place is 6. We already have 2. Let's be wise. What should, let's take X up. What should be here? Here should be 3. Let's be wise. Because if here is 3, 3 is going to affect everything, all the elements. So when 3 affects all the already, listen, you know, this 3 is times 10. Anything is. So already we're having 2 nitrogen. So 3 times that 2, what is that? 6. 3 times 2, what is that? Do you understand? 3 times the 2 already for nitrogen, what's that? 6 nitrogen here. So 6 nitrogen in this place plus 2 nitrogen here. What is that? 8 nitrogen. So we've already balanced nitrogen. I believe you understand what's happening. This question is very simple. Just listen, watch the video step by step. Don't skip any part of this lesson. The reason I'm taking my time, so when you see other questions, because I'm going to give you a practice question, you can solve it without stress. So you can see that we putting 3 in front of this compound has altered every other thing. Remember, this is the right hand side. So we are actually altering the right hand side. We have no business with left. We make sure we talked about left already. So first of all, let's do this. Copper now, 3 copper. So copper is now 3 in the right. Wow, copper in the left is 1. What should I do to copper in the left to make sure that it's still 3? It's simple. It's just to remove this my x and put 3 here, because nothing is just copper alone. So here we have 3 copper. Do you understand what is happening? So let's analyze everything in left and right again. So copper in the left 3, copper in the right 3, nitrogen 8, and nitrogen 8 in the right and left balance, nitrogen 8 balance as well. So what is remaining not to be balanced? It is simply oxygen. So we've actually balanced oxygen, but we have to be careful. Let's look at everything again. So oxygen here already is 2 times 3. 2 times 3, that is 6. 2 times 3, what's that? 6. So 3 standing in front of the compound is timesing everything. So 3 times the oxygen, that is 6. So 3 times 6, what is that? 18 oxygen. Are you there? 3 times the 6 oxygen, 18. Oxygen here alone. Is it up to 24? No, we are not done. So here now in water, how many oxygen can you see? I can see 4 oxygen, because 4 is times O, that's 4 oxygen. So 4 oxygen plus 18 oxygen here, what's that? That is 22 oxygen atoms. Are you there? So it's not still up to the one we had at our left hand side. Let's check the other guy, the other compound remaining. 2 times the oxygen, that is 2 oxygen here. So 2 plus the 22 we've gotten in these 2 sides, making it to be 24 oxygen. 24 oxygen. Wow, we balance it. Remove 11 and put 24 oxygen atom. In my right, left, they are all balanced. All the elements in my left and as well as my right hand side are all balanced. All right, 3 3 8 8 8 8 24 24. Wow, so let's now get the answer to this question. So what do we do? Listen, that's why I had to write them anything I change, I'll put it on top so we don't get confused. All of these are the ratios to which the answer are arranged. The answer are arranged in this ratio: x, y, and z. So any number we're saying first is x, the next is y, and the last is z. Are you there? So first, let's get our x, let's get our y, and let's get our z. All right, remember x stood here, so x was here initially, so x is what? 3. Any place you see x is 3 automatically. It's simple. But hold on, let's check for y. Y was here, y is 8. So under y I'm going to put 8. Are you there? All right, this is the x. I told you anyway you see x is same number. So this the x is still 3, so we are okay. You can see we are on track. Y, z now, z is 2. Z is 2. Are you seeing it? So the answer to this question should be 3:8:2. Wow, let's get the answer. 3:8:2. So the answer to this question becomes option B. You can see how questions under balancing chemical reactions are solved without stress. So if you find my video lesson helpful, Make sure you click on the subscribe button to my channel and also share my lessons with your friends. All right, and get ready for your own practice question. To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen. Okay, guys, here is your own practice question. So you solve and provide the answer in the comment section. You have to balance both reactions. All right. So you can see I did not really put XYZ, but the reason I had to solve that question because that question was a jam pass question. You can see it's very technical but simple. But here, from this question alone, they can actually formulate that same type of question. So the most important thing for you to make sure you know how to balance a chemical reaction. So if they give you that, you can still solve it. Just for you to be calm and take it step by step the way we solve that question. All right. So we've come to the end of this lesson. If you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share with your friends. Thanks for watching.